All right, so we have 4 graphs for homework. And I just want to remind you of what we did in our notes. Based on which trig function you see, it's a good idea to write out what the nice values are that you should be plugging into your table. So cosine of 0 is 1. Cosine of pi over 3 is 1/2. Cosine of pi over 2 is 0. Cosine of 2 pi over 3 is negative 1/2. And I always do this to pi, so cosine of pi is negative 1. We might need more points than that, but that gets me started and reminds me to use the pi over 3 angles. Now, if you can remember to use the pi over 3 angles, then you don't really have to do that. But I think it's just nice to have. We're plugging theta into 1 plus 2 cosine theta. And we always start at 0 no matter what r is equal to. So if I plug in 0, I get 1 plus 2 times cosine of 0 is 1. I get 3. It's a good idea to plot as you go. So face 0 and go 1, 2, 3. Here's our first point. Then we're going to plug in pi over 3, and we get 1 plus 2 times cosine of pi over 3 is 1/2. 1 plus 1 is 2. Face pi over 3 and go forward 2 units. So far we've got this graph going on. And then we have pi over 2. That's 1 plus 2 times cosine of pi over 2 is 0. Face pi over 2 and go forward 1. Now, I'm not happy with how wobbly that was. So these are hard to sketch in their proper rotation, but we started here. We've got this so far. And then we're going to plug in 2 pi over 3. That's 1 plus 2 times negative 1/2. The cosine of 2 pi over 3 is negative 1/2. So that's 1 minus 1, which is 0. Back to the pole here, or the origin, I should say. All right. And then the next point that I'm going to plug in is after 2 pi over 3 would be pi. 1 plus 2 times cosine of pi is negative 1. 1 minus 2 is negative 1. So when we face pi, we go backward 1 unit. We're right here. And I know that this dips below the axis because, again, we have to spiral counterclockwise. So think about a spirograph. You have to go in this order. It's not going to go like this and then bump up like that. And then I need to keep going with pi over 3 angles. So the next angle after pi would be 4 pi over 3. 1 plus 2 times cosine of 4 pi over 3 is also negative 1/2. 1 minus 1 is 0. So now I'm back to 0. Again, pretend this is like a spirograph thing and you plot here. Now you might realize there's symmetry after this, and the next point you could plot to match with the other 2 points. Or if you're not sure, just keep going. After 4 pi over 3, we plug in 3 pi over 2. 1 plus 2 times cosine of 3 pi over 2 is 0. So face 3 pi over 2 and plot 1, which is where I put that point for symmetry. Let's see if this point matches up next. Next point is 5 pi over 3. 1 plus 2 times cosine of 5 pi over 3 is positive 1/2. 1 plus 1 is 2. So, yep, face 5 pi over 3 and walk forward 2 lands me here. And then when I plug in 2 pi, I should get the same answer I got with 0, right? Because those are coterminal. So that should finish the graph here. So this is one of those. I think it's called I forget if it's limacon or limacon. I think it's limacon with a loop. I'm having a hard time connecting this. You want these to look rounded. But again, it's nice to know that the graph started here and traced around this way. If you're taking BC Calculus at the end of the year, we will be finding like the area in between these 2 loops and things like that. So we do more with this in BC. All right, what about this one? This is 6 times the sine of 2 theta. So I'm going to make a couple notes for myself here. 2 theta means there should be 4 petals. 6 is like the max length of a petal. The furthest from the center to the end of a petal is going to be 6. And remember, we had nice angles that we put in for sine. Sine of 0 is 0. Sine of pi over 6 is 1/2. Sine of pi over 2 is 1. Sine of 5 pi over 6 is also 1/2. And sine of pi is 0. But we have 2 theta. So remember, we need to say, well, 2 theta equals 0. So theta equals 0. 2 theta needs to equal pi over 6. So the angle that I'm really plugging in is pi over 12. I know I don't have that marked off here, but it's easy to say halfway between 0 and pi over 6. So let's mark that off, 0 and pi over 6. And then here, 2 theta equals pi over 2, so theta equals pi over 4. So we're going to need, I don't have that marked off either, so here's pi over 4. And then 2 theta equals 5 pi over 6. So theta equals 5 pi over 12. We did this in the notes, remember? So 5 pi over 12 is this angle that's between pi over 3 and just short of pi over 2. So here's 5 pi over 12. And finally, 2 theta equals pi. So we're going to need pi over 2. All right. Now I like to make a little chart so that I can just keep everything organized. So even though I've done a lot of the work here, I'm going to translate this to my chart. So I need to start by plugging in 0, and I get 6 times the sine of 0, which is 6 times 0. So the first point is at the origin. It will always be like that for a rose curve that has sine in it instead of cosine. So remember, we made that note on our notes as well. And then the tip of the next petal should be in quadrant 1. So let's see. We put in pi over 12. This is going to give us the width of the petal. That's 6 times the sine of 2 pi over 12 is pi over 6. 6 times 1/2 is 3. So at pi over, this should say pi over 12. Sorry about that. At pi over 12, we're going to go forward 1, 2, 3 units. And then we're going to plug in pi over 4. So I did this, now I'm here. That gives me 6 sine of 2 pi over 4, which is pi over 2. 6 times 1 is 6. So the end of the petal is 1, 2, 3, 4, 5, 6. It's right here. So far we have this much of the petal. All right. And then at 5 pi over 12, we're going to get 6 sine of 5 pi over 6 when we multiply that by 2. 6 times 1/2 is 3. So remember, there's symmetry happening. You could be using symmetry already, maybe to finish off the first petal. And then when we get back to pi over 2, we're going to get 0 because 6 times the sine of 2 pi over 2 is the same as 6 times the sine of pi, which is 0. Here's one petal. Now, if you can remember what happened with the last one, I have 4 petals, so I know that the next petal is going to dip down into this quadrant here, into 4th quadrant, and it's going to be at the pi over 4 angle and these halfway points, these pi over 12 points where I have the width of the petal. So I could use symmetry from right here. Or if you're not sure about that, because sometimes this is hard for people to visualize, like where it's going to go next, just plug in the next angle. Remember, the next one would be 7 pi over 12. 7 pi over 12. That's going to give you 6 times the sine of 7 pi over 6, because you're multiplying by 2. That's 6 times negative 1/2. So that's negative 3. So face 7 pi over 12, but go backward 3. So you're really on this pi over 12 line. I don't really care what it is. And then I'm going 1, 2, 3, back this way. Now that should be enough to tell you the next petal is down here. So let's just use symmetry at this point. At pi over 4, I should be out 6, just like I was on the first petal. 1, 2, 3, 4, 5, 6. And then at the other pi over 12, I should be out 2. So here's the next petal. Okay, and then think about how this traces. So it started here, we went around quadrant 1, around here. Where does it have to go next? It next has to go into quadrant 3. Oops, my pen stopped working. Get that recharged there. Okay, so here are my markers so my eyes follow the right line. So in quadrant 3, we're out 2 for the width. And then 1, 2, 3, 4, 5. Oh, sorry, not out 2. Out 3. That did look a little Whopper Judd, didn't it? 1, 2, 3, right there for that one. And then out 3, half of the petal length. 1, 2, 3. There we go. And then out 6. 1, 2, 3, 4, 5, 6. And then out 1, 2, 3. So here's the next petal. And then the fourth petal is going to go into quadrant 2. It always goes in this order too. So 4, 5, 6, 1, 2, 3. So when we're doing these rose curves, the sine curve is going to follow that pattern. It's going to be quadrant 1, quadrant 4, quadrant 3, quadrant 2. I'm not going to give you a million petals either, so maybe 6 would be the max, I guess. Another thing to take note of is the tips of the petals are all the same distance apart. If you count how many of these, it's like 1/2, 1, 2, another half, 1/2, 1, 2, another half. That gets you from tip to tip, if that helps as well. All right, let's do number 3. So I'm not going to make my little chart ahead of time for 2 reasons. I'm running low on time, but also we've generated this a few times. Once you get the nice values for sine in your head, if it's not sine of 2 theta or 3 theta, it's easier to plug in. Start at 0. 1 minus 2 times the sine of 0. So 1 minus 0 is 1. Face 0, walk forward 1. Pi over 6. 1 minus 2 times the sine of pi over 6 is 1/2. 1 minus 1 is 0. So far, our curve looks like this. Then we plug in pi over 2. 1 minus 2 times sine of pi over 2 is 1. 1 minus 2 is negative 1. Face pi over 2, but go backward 1. So now you look like that. 5 pi over 6. 1 minus 2 times, again, positive 1/2 is 1 minus 1, which is 0. So back to the origin. Then pi. 1 minus 2 times sine of pi is 0. 1 minus 0 is 1. So I see a bit of symmetry happening here. And then 7 pi over 6. 1 minus 2 times negative 1/2, sine of 7 pi over 6. So that's 1 plus 1 is 2. All right, so here's 7 pi over 6. Walk forward 2. So this is sort of widening. This is one of those limacons with a inner loop. And then 3 pi over 2. 1 minus 2 times negative 1 is 1 plus 2, which is 3. And maybe you're okay with symmetry at this point. The next point at the other pi over 6 should be just as far out as the 7 pi over 6. Or plug 11 pi over 6 into that and see what you get. And then when you plug in 2 pi, you would land at the same place as plugging in 0. Try to round this out better. Okay, last one. This time it's cosine. We've got 2 theta, so let's generate these numbers. So cosine of 0 is 1. Cosine of pi over 3 is 1/2. Cosine of pi over 2 is 0. Cosine of 2 pi over 3 is negative 1/2. And cosine of pi is negative 1. Now we have 2 theta. Again, there should be 4 petals. 5 is going to be the max length. And this is cosine, so it should be starting on the x-axis. We want 2 theta to equal 0, so theta will always start at 0. We want 2 theta to equal pi over 3, so we're really going to be plugging in pi over 6. We want 2 theta to be pi over 2, so pi over 4. 2 theta, 2 pi over 3. When I divide by 2, I get pi over 3. And when I want 2 theta to equal pi over 2. So look at this one. We're basically plugging in every quadrant 1 angle, right? Okay, so theta into 5 cosine 2 theta. When you plug in 0, you get 5 times the cosine of 0, which is 5 times 1. So 1, 2, 3, 4, 5 right here. When you plug in pi over 6, you get 5 times the cosine of pi over 3, because it's 2 pi over 6. 5 times 1/2 is 2.5. So we plugged in pi over 6. We're going out 2.5. When we plug in pi over 4, we get 5 times cosine of pi over 2. That's 0. And when we plug in pi over 3, we get 5 times the cosine of 2 pi over 3, which is negative 1/2, so negative 2.5. So when we face pi over 3, here we are so far. We don't finish the first petal. We go down to negative 2.5, so we're like out here. And then when we plug in pi over 2, we get 5 times the cosine of 2 pi over 2, which is negative 5. So face pi over 2, but go down 1, 2, 3, 4, 5. Is this enough to help you figure out the symmetry? I think so, because I can see the petal tips are all going to be, there's 4 petals. They're all going to be on the axes. And the width is happening at the pi over 3 angles and the pi over 6 angles, right? So this one has to go like, it's equidistance. This is like half a petal right here. So you have to go out 2.5 right there. I can finish this petal by saying it's going to be 2.5 here. See how that's the same distance away. I can do the other petals, 1, 2, 3, 4, 5. And on this line, 1, 2.5. On this line, 1, 2.5. Here are the next 2 petals. And the last petal, 1, 2, 3, 4, 5. Here's the length of the petal. And then out 2.5 on either line. So should you really be plugging in a million of these little angles, every single angle around the unit circle? No, you could, but you also want to use the idea of symmetry. Again, especially if you're going to be taking Calc 2 at some point, because we do use the fact that we can figure out what the area of a petal is based on symmetry, like what its bounds are, more than having to graph the whole entire thing. All right, that's it for this worksheet.